In this example, the masses of Arctic foxes are found and the mean mass was 6.1 kilogram, the variance was 4.2, and outliers of an observation was lies plus minus 2 standard deviation from the mean. For part A, which of these Arctic fox masses are outliers? So we have 4 values here. So we start with finding, we know the mean is equal to 6.1 kilogram, and we have also standard deviation equal to square root of 4.2. So we have mean taken away from 2 multiplied by standard deviation, which will give us 6.1 minus 2 multiplied by root of 4.2, which will give us 2.00. So this will be for the negative term. For the positive, plus 2 multiplied by standard deviation, which will give us 6.1 plus 2 multiplied by root of 4.2, which will give us in this scenario 10.2. Now, so in this scenario, that will prove to us because the values are lower, so that we'll say 11.5 kilogram, which is the largest value, is an outlier, and this will be our answer for part A. For part B, what are the smallest and largest masses that an Arctic fox can be without being an outlier? So based on the data that we have, we can say that the lowest is 2. So we say the lowest or smallest is 2 kilogram, and the largest is 10.2 kilogram, and this will be our answer for this question. In this example, the ages of 9 people at a children's birthday party are recorded. The sum of data are 92, and the sum of x squared equal 1428. First, calculate the mean and the standard deviation of the ages, and outliners of an observation which lies plus minus standard deviation from the mean. One of the ages is recorded as 13. So first, we'll start with finding the mean. So in this scenario, will be the summation of x divided by the number of data. So in this scenario, we have 92, and we know that there is 9 children attending, so that will give us 10.2, which will be the mean value. To find the standard deviation, so that will be the root of x squared, summation of x squared over n, taken away from summation of x over n, all squared, under the square root. So in this scenario, we will plug the values, so that we would have 1428 over 9, taken away from 92 over 9 squared, all under the square root. So that will give us approximately 7.36, which is the value for the standard deviation. Now, for part B, we need to state with a reason whether this is an outlier. So first, for part B, we need to find the mean and the range in terms of standard deviation. So we have the negative, in terms of finding the outlier, the negative part will be mean take away 2 multiplied by the standard deviation. So that would give us, in this scenario, minus 4.5 when we plug the values. And when we use the positive mean by standard deviation, that would give us 24.9. Now, in terms of the outlier, so we say in this scenario 30 is an outlier, because minus 4.5 is smaller than 30, and 30 is also bigger than 24.9. So in this scenario, as it is more, so we say 30 is bigger than minus 4.4, and also 30 bigger than 24.9. Now for part C, we are asked to suggest a reason why this age could be a legitimate data value. It could, so we say it could be the age of a parent at the party. Now for part D, given that all 9 people were children, clean the data and recalculate the mean and standard deviation. So in this scenario, we need, for part D, we have the summation of x, we take away 30 from it, and that would give us 92 minus 30, which will give us 62. Now to find the mean, we would have 62 over 8, because we reduced it by 1 attendee, and that would give us 7.75. Now to find the standard deviation, we have summation of x squared minus 30 squared, so that would give us in this scenario 1428, take away 900, which will give us 528. Now to find the standard deviation, we would have the square root of 528 over 8, take away 62 over 8 all squared, and that so simplifying this expression, the square root, that would give us 2.44 as the value for the standard deviation, and this will be our answer for this question. In this example, the length in centimeters of 12 giant African land snails are given below, and the data shown here. So for first part, we've asked to calculate the mean and the standard deviation, given that sum of data is 200, sum of x is 252, and sum of x squared equal 5468. So for part A, we are asked to find the mean, which will be the summation of x divided by the number of values. So in this scenario, we have 252 divided by 12, so that will give us 21 centimeters. So that will be the mean value. Now for us to find the variance, we would have the summation squared over n. So in this scenario, and also taken away from x squared dash. So in this scenario, we would have 5468 divided by n. In this scenario is 12, taken away from 21, which is the mean value that we found, squared. So the value in this scenario, it will be 14.666. That's to 3 decimal places. Now the standard deviation in this scenario, we say standard deviation will equal the square root of the variance that we just found, which is 14.666. So in this scenario, the value that we have to 3 significant figures will be 3.83. So that represents the standard deviation. Now for part B, we are asked to find an outliner is an observation which lies plus minus 2 standard deviations from the mean. Identify any outliers from this data. So we have the mean taken away from 2 multiplied by standard deviation. So in this scenario we have 21 taken away from 2 multiplied by 3.83, so that will give us 13.84, 13.34. So this will be the expression that we find for the positive, for the negative values. Now we find the mean plus the positive, multiplied by standard deviation. So that will give us 21 plus 2 multiplied by 3.83. So that will give us 28.66. So in this scenario, we can see that the value of 32 centimeters, so you can say 32 centimeters is an outlier, as the values of 13.3 is smaller than value, and also 28.66 is smaller than the value of 32, and this will be our answer for this question. In this example, some data is collected. Q1 is 46, Q3 is 68. A value greater than Q3 plus 1.5 multiplied by Q3 take away Q1, or smaller than Q1 take away 1.5 multiplied by Q3 take away Q1 is defined as an outlier. So first we need to find, before we start part A, we need to find the difference. So say IQR, which is the difference between Q3 minus Q1, would give us 68 minus 46, so that would give us 22. And we also to find the greater and the lower value, so we say 46 minus 1.5 multiplied by 22, and that would give us 13. And we also have 68 plus 1.5 multiplied by 22, and that would give us 101. So now we can attempt to find, work out whether the following are outliers. So we start with part A. So we can see that 7 is an outlier, as 7 is smaller than 13. For part B, we have 88. So 88 is not an outlier, as 13 is smaller than 88, and also is smaller than 101. Now for part C, we're looking at 105. So 105 is an outlier, as 105 is bigger than 101. Okay, so this will be our answer for this question.